All right. Thanks for joining me. We're going to talk about chapter 1.2. Let's get her zoomed in here. And it's talking about linear applications. Okay, so our objective is to solve problems using linear models. And that's just a fancy way of saying we're going to solve word problems. So solve word problems using linear equations. Okay, so no x squared or x to the third or anything like that. So we've got some steps here. We want to identify the question. Really pay attention and ask what is this word problem asking me to do, and what kind of answer should I be getting. You can always make notes on the word problems of what's important, what's not important. Assign a variable. Usually we use x. You might say x equals time or something like that. So you need to make sure you understand what your variable represents. Now you're going to set up an equation. This is a must. Okay, I'll be looking for your equations when I go to grade your test or I grade your quizzes or something like that. I'm going to be looking for your equation. You're going to solve the equation and get an answer and label it. Again, if you don't have a label, it is wrong. And then if you feel like you need to, definitely check your solution out. Okay, so during a camping trip in North Bay, Ontario, a couple went 1/3 of the way by boat, 10 miles by foot, and 1/6 of the way by horse. How long was the trip? So here's the question. How long was the trip? So we're going to say X will be the length of the trip. So in my trip here, it's split up into sections. Okay. So here I have, they went 1/3 of the way by boat. So 1/3 of this trip was by boat. So 1/3 of the whole thing was by boat. Plus, we've got 10 miles by foot. So they went 10 miles of this total trip was by foot, and 1/6 of the way by horse. So 1/6 of the way by horse. Now remember, of means multiply. So here and here you see the word of. That's how I know I'm going to take 1/3 of x, 1/6 of x. Okay. So we've got everything in our equation here. So this is what we want. So we'll simply take this whole thing times our common denominator, which is 6. That's what we did in 1.1. So then we'll distribute. So 6 times x is 6x. 1/3 x times 6 is 2x. 6 times 10 is 60. 6 times 1/6 x is x. Again, this was chapter 1.1, solving linear equation. So we'll subtract 2x, get everything on one side. All your x's on one side, all your numbers on the other. So then we will have 3x equals 60. Divide by 3. X is 20. Okay. We'll look back up at the question, how long was the trip? Well, 20, and if we look through the problem, we can see that I had a miles label. So our trip was 20 miles long. Okay. So let's look at the next one. Okay. Find 3 consecutive even integers so that the sum of the three numbers is 2 more than twice the third. We're going to start by this problem. This is a really important problem. They make good ACT question problems. Okay, so find 3 consecutive even integers. That's like 2, 4, 6. Okay, we're looking for some kind of numbers like that. So I've got the first, the second, and the third. Okay, if we let the first number be x, to get to the second number, we just add 2. We're adding 2 to get there. So we'll have x plus 2. And to get to the third, we're going to add 4. For another example, if we do 10, 12, 14. This is x. This was plus 2. 14 was 4 more than the 10. Okay. So these are the numbers over here we're going to use. So then we plug it in. The sum of the 3 numbers, so we'll take x plus 2 plus x plus 4 is, so equals 2 more than twice the third. So we got twice the third, so 2x plus 4. And it says here the sum is 2 more than twice the third. So this side over here is 2 more than this side over here. So to make them balance out, kind of thinking of a scale here, we have to add 2 more to this side so that they are equal. Okay. And plus it says equal here, so is 2 more. So that means you're going to add 2 to this side over here. Okay, so you have 3x plus 6, 1, 2, 3, equals, that gives you 2x. That gives you 8. You have 8 plus the 2 makes 10. Minus 2x, minus 2x, you get x, minus 6, minus 6, you have 4. So x is 4. So 4 was my first number. My second number is 2 more. And my third number was 4 more. So there's my 3 consecutive even integers. Okay. Now let's talk about this, because we can do a couple other different types of problems with this. If we say odd here, if we say consecutive odd integer, okay, like 1, 3, 5. Are these going to change from my first, second, and third? No, because if this is x, I add 2 to get 3, and I added 4 to get 5. So I'm still using these right here. Let's say consecutive integers. Okay, just regular consecutive integers like 1, 2, 3. Will these change now? Well, sure they will, because if this is x, then this will become x plus 1, and this will be x plus 2. I had 1, added 1 to get the 2. From the 1, I added 2 to get to the 3. Okay, so this is some important stuff right here. We'll need to know that. Sometimes it's nice to draw pictures with word problems. So a rectangle 24 meters long has the same area as a square with 12-meter sides. What are the dimensions of the rectangle? So I have this rectangle here, and the area of that rectangle will be the same as the area of some square over here. Well, the dimensions of this rectangle is 24 by x. We don't know this. It didn't tell us up here. The square has 12 meters by 12 meters. So here's my equation. Here. So we'll say 12 times 12 is 144. That's the area of the square. The area of this rectangle will be 24 times x, which is 24x. Divide by 24. Divide by 24. X equals 6. Then it says, what are the dimensions of the rectangle? Well, the rectangle is 6 meters by 24 meters. That is my answer. Again, make sure we have these labels on here. If it doesn't have labels, let's say I didn't put the meters and I didn't put the meter there. Okay, so if it doesn't have meters, feet, inches, all that kind of stuff, we put units. So if it has no label, in the problem, put units on everything. Okay. put units on everything. Simple interest. All right, so I have I is your interest. P is going to be your principal or your start amount. Your start amount. R is rates, your interest rate, your annual percentage rate, it is in years, and T is time. Time is also in years, okay? So that just kind of outlines what everything is. Okay? So if we look at a problem with interest, through a summer job, Morgan is able to save $2,500. If she puts that money into a 6-month certificate of deposit, CD, that pays a simple interest rate of 3% a year, how much money will she have in her CD at the end of 6 months? Okay, a CD is like you loaning your money to the bank. Okay, I give my $2,500 to the bank to borrow. They're going to pay me 3% for 6 months. Now, if I want this money out before 6 months, I'm going to have to pay a fee, okay, to get my money back. You're letting them borrow it for 6 months. Okay, so we're going to look, the interest is PRT. So my principal is the $2,500. My rate is 3%, so that's 0.03. And I'm doing it for 6 months. Now remember, T is in years. So this is 0.5 years. 6 months is half a year. Then I'll just put that into the calculator. And we'll get 37.50. Okay, that's how much she's making at 6 months. But it says how much is in her CD at the end. Well, we also put in the $2,500. So then we have 2537.50. That's how much is in her account after 6 months. All right, Teresa earned a full athletic scholarship for college, and her parents have given her $20,000 they have saved to pay for her college tuition. She decides to invest that money with an overall goal of earning 11% interest. She wants to put some of the money in a low-risk investment that has been earning 8% a year, and the rest of the money in a medium-risk investment that earns about 12% a year. How much money should she put in each investment to reach her goal? Okay, this is kind of like a chemistry mixture problem here. Okay, so what we're going to do is we're taking our 8% and our 12%. So we got 8% plus our 12% to reach our goal of 11%. Now, our goal has a total of $20,000. So we're going to say we have 11% at $20,000. Okay. Now, how much am I investing at 8%? Well, I don't know. So we're going to put X. How much am I investing at 12%? Well, I had $20,000 to start with. I already invested X amount over here, so the rest of it goes here. So here's going to be 20,000 minus X in that case. Okay. So then I just distribute. But you notice I've got percentages on every term, so we can cancel out my percentages on every term. So I have 8X equals, distribute this. Oh, that's a plus, not equals. 240,000 minus 12X equals 220,000. So I have 8X minus 12X minus 4X if I subtract the 240,000, I get negative 20,000. Divide by negative 4, x is 5,000. So what does this mean? Well, if we look back up here, x went with the 8%. So we'll have $5,000 at 8%. Okay. And then 20 minus 5,000 is 15,000 at 12%. So there would be my answer. Okay, so make sure we're not, putting in two different labels or two different variables. We have the same variable and we're not putting the same. This is an x, and this is an x. We've got to have the difference in there somewhere. The manual for your new car suggests using gasoline that is 89% octane. In order to save money, you decided to use some 87 and some 93 octane in combination with the 89 currently in your tank in order to have the approximate 89% octane mixture. Assuming you have 1 gallon of 89 remaining in your tank and your capacity is 16 gallons, how many gallons of 87 and 93 should you use? Okay, first off, don't ever mix gasoline in your car. That's not a very smart thing to be doing. But we're going to mix together 89, 87, 93 for our goal of 89. Okay. Again, this is our ideal equation. This helps us get things set up. So we're going to take 89, and we have 16 gallons as our goal. Okay. All right. Coming over here is that I have 1 gallon of 89. So I already have 1 gallon of 89. Plus, I don't know how many gallons of 87 I have. So there's my variable. Plus 93. Well, that's what's left over. So I had 16. I used 1 gallon here. So that's 15 gallons left. And I used x gallons here. So I've got 15 minus x. And there's my equation. So we'll just multiply everything out. 93 times 15 is 1395 minus 93x equals 89 times 16, 1424. All right, so I have minus 89, minus 89, minus 1395, minus 1395, and you get negative 60. And then you have 87x minus 93x, so that's minus 6x. Divided by negative 6, x is 10. So you have 10. Now, read back up through your problem here in this equation right here, okay, and you'll see that x goes with 87. So you have 10 gallons of 87 and 15 minus 10, 5 gallons of 93. And if you want, you can put 1 gallon of 89. But again, the question just asked for how many gallons of 87 and 93. So really, these two right there were the only ones really needed. Okay. All right, it takes 8 hours to fly from Orlando to London, and it takes 9.5 hours to return. If an airplane averages 550 miles in still air, what is the average rate of the wind blowing in the direction from Orlando to London? Assume the speed of the wind or the jet stream is constant and the same for both legs of the trip, round to the nearest mile per hour. So we're going from Orlando to London, and we're going back. Okay. The trip there, Orlando to London, takes 8 hours, and the trip back takes 9.5 hours. Okay. In still air, I'm going 550 miles an hour, but we have this jet stream. Okay. Well, just looking at the times, I can see going there, I have to be going faster because it takes less time. So I start at 550, but because the air is pushing me faster, we add the wind speed in. Now on the return, it takes longer, so we'll do 550 minus the wind speed because it is pushing against me. It takes longer. Okay. Now, what do we know about the distance between Orlando and London? It is the same both ways. And we know that distance equals rate times time. So I have my rate and I have my time. I have my rate and my time. So I'll just set them equal. So I have 8 times 550 plus W equals 9.5 times 550, that's a 50, minus W. Again, I just distribute, combine like terms, get W on one side. So I have 4,400 plus 8W equals 5225 minus 9.5 W. So then we will plus 9.5 W plus 9.5 W, 17.5 W, and we'll subtract 4,400. So 825 divided by 17.5 divided by 17.5, you get W to be 47.1428 and such on, but it says round to the nearest mile per hour. So the wind is 47 miles per hour. Now go back. Does that answer the question? It says, what is the average rate of the wind blowing in the direction of Orlando to London? So it just wanted the wind speed. So we did answer the question. We do these types of problems with river, canoeing downstream and then back upstream, or kayaking, or stuff like that. Anything that combines two moving objects, or one moving object and wind or water or something else moving. Connie can clean her house in 2 hours. If Alvaro helps her, they can clean the house in 1 hour and 15 minutes together. How long will it take Alvaro to clean the house alone? Okay, another star question. This is a really good question. Okay, so we set up a table on these types of problems. Okay, so we look at Connie, Alvaro, and them together. So Connie can clean the house in 2 hours. So this is time, and this is rate. Okay, so she can clean the house in 2 hours. Now, how much house can she clean in 1 hour? This would be our unit rate. She can clean half of the house in 1 hour. And then how long does it take Alvaro? We don't know, but his unit rate we do know. Okay, if it takes him X hours to do the whole house, it will take him. He can do 1 over X in 1 hour. Okay, all we're doing here is we're just doing the reciprocal. It was 2 over 1. We have 1 over 2. It was X over 1. And it's 1 over X. This is our unit rate. Together they can do 1 hour and 15 minutes. Well, I need a fraction here. An hour and 15 minutes is 1 1/4 hours. Okay, so 1 1/4, so that would be 5 over 4 to do the whole house. Well, their unit rate, how much house can they clean in 1 hour, is 4/5. So then we're going to use this column right here to set up an equation. Okay, over here we're comparing apples, oranges, and bananas. Okay, then when we come over here, we've changed it all to the same thing. Okay, now it's all pineapples, or it's all the same over here. So now we have 1/2 plus 1 over x equals what they can do together. And again, this is 1.1 stuff. So we're going to take the whole thing and we're going to multiply by the common denominator, which is 10x. Then we're going to take that and back distribute it in. So you have half of 10x is 5x plus 1x of 10x is 10. 4/5 of 10x is 8x. Again, 10x times 4 is 40x. 40x divided by 5 is 8x. Minus 5x. 10 equals 3x. Divide by 3, divide by 3. X is 10/3. Now, what does that mean? How long does it take him to clean the house? Well, 10/3 is the same as 3 1/3. So that's 3 hours. And 1/3 of an hour, that's 60 minutes divided by 3 is 20 minutes. So it takes him 3 hours and 20 minutes. Okay. Make sure you're setting up this table correctly. Okay. If you try to do it without the table, it's going to get a little bit confusing. All right. So here's your suggested problems in chapter 1.2. Give them a try, and we will quiz the next day in class. I hope this helped, and this is at THS Mr. Jones signing off.